So this is question 16a of the 2016 HSC paper. It says a particle moves in a straight line and it gives us the equation of the velocity in terms of time, and so it says first find the initial velocity. So with the initial velocity, what that means to us is that it's the start of the particle's journey, so no time has passed, which means that t equals 0. That's what the word initial means, right? So we can sub that into the equation they've given us, and we find that the initial velocity is negative 2 meters per second. Second question says find the acceleration of the particle when the particle is stationary. So what does acceleration mean to us? It means the rate of change of the velocity. So how fast is the velocity changing over time? We calculate this by getting dv dt. Okay, so we have to differentiate the velocity. So before we differentiate that, we should see the fraction 4 over t plus 1, and we should rewrite that as 4t plus 1 to the negative 1. Okay, so we want to differentiate that one instead. And so, of course, the 2 will vanish, and the negative 1 hops down, leaving you with a positive 4. Then you get a power of negative 2. Okay, and so that we can rewrite as 4 over t plus 1 squared. Okay, but that's the acceleration of the particle at any given point in time. They want one particular value of t for when the particle is stationary. So what does that mean? It means it's not moving, which means that v equals 0. Okay, so now we sub in, well, what does that mean for v to be 0? Well, it means that 2 minus 4 over t plus 1 is 0. And so we can quickly solve this equation, and we find that t equals 1 second. So at time t equals 1 second, 1 second into the particle's journey, it is going to be stationary. Okay, and we can now sub that back into that expression we found for acceleration. And so we sub it in, and we get some quick math that will be 1 meter per second squared. Okay, the next question wants us to graph it. It says by considering the behavior of v for large t. But before we even do that, hopefully just by looking at that equation up there, we can see that it's going to be a hyperbola. Okay, so that we should know is going to be the shape of the graph that we get. So let's draw some axes. And before we look at the behavior of v for large t, let's remember back to part 1, the initial velocity is negative 2. Okay, it's going to be helpful because that's a starting place for us. Okay, so now the behavior of v for large t, what does that mean? Well, it means as a lot of time passes, so as t goes to infinity, what's going to happen? Okay, so hopefully you can see as t gets very, very big, you'll have a fraction with 4 on top and a very big number on the bottom. Okay, and that's going to go to 0, it's going to vanish, okay, because you've got a huge number on the bottom. So that means the v becomes 2 minus a tiny, tiny number, very close to 0. It will never get to 0, but it'll get very close. Okay, and so you're going to be just a bit under 2. We write this as v tends to 2 minus. So now we can draw, I guess, a little skeleton of what it's going to look like. We know we start at negative 2, and we are going to approach 2, but never get there. We're going to hover just underneath it. Okay, and so we draw a hyperbola kind of shape, and off we go. That's going to be our graph. Last thing to do, the question does say showing any intercepts. Now we've got the v-intercept already. We just need the t-intercept. Okay, but now if you want to just rewind back to part 2 or something, some of the working we saw there showed that the velocity is 0 when t equals 1. So that tells us from the previous part that that intercept is going to be 1. Alright, and the last part, find the exact distance traveled by the particle in the first 7 seconds. So before we go at this one, I think I might just bring back the graph a little bit, okay, because what I want to show is the trajectory of the particle. It's going to be very important in calculating this, okay, because to get the distance or to get displacement, we always integrate the velocity, okay, but we can't just integrate from 0 up to 7, okay, and this is why. I'm going to put 2 markers here, okay, so you can see one marker is going to be here. It's going to trace a path along the graph. This one's going to actually be the particle, okay, I'm going to try and model how the particle is going to be moving. Okay, I'm going to call left the negative direction, and write the positive direction as we normally do. Okay, so because the velocity starts at -2, we're going to expect the particle to start off shooting to the left. Okay, so let's have a look. It's going to shoot to the left, it's going to then stop at 1 second. Okay, now of course time doesn't stop like this, but it's going to go to the left, it's going to stop, and then as time continues to pass, okay, the velocity goes positive, which means the particle turns and moves back to the right, like so. Okay, so I broke it up there into sections just so you could see what's going to happen. Okay, I'm going to do it again, but this time we're not going to stop. Okay, so it's going to shoot to the left, it's going to stop, then it's going to go back to the right. It's going to bounce back like that. Okay, I've kept a little shadow to show where it started over here. Okay, and that's the trajectory. Okay, so why is that important? So again, it's because we can't just integrate to find distance, and I'm going to show you why. I'm going to play it one more time, but this time I'm going to actually look at what's happening. So it's going to the left, it's stopping. So this is from time equals 0 to time equals 1. Okay, so that's when it's traveled this far here. Now this is negative distance, remember that, okay? And then it's going to go forward again, and it's going to stop at 7 seconds, say. And so this is time from 1 up to 7. And so why we can't just integrate from 0 to 7 is because the distance traveled here is going to cancel the distance traveled here. Okay, because this one's negative, this one's positive, they're going to cancel each other out when we integrate. Okay, it's the same as how when we just integrate from 0 to 7, the area down the bottom here, the negative area, so to speak, will cancel some of this positive area. It's the same thing going on here. Okay, so that's why we've got to split our journey into two paths, one from t equals 0 to 1, and one from t equals 1 up to 7. Okay, so let's get rid of the graph now, we don't need that anymore. We're going to see that there's two lengths of the journey. One's a negative distance, where we're integrating from 0 to 1. Okay, now the integral of this, 2 becomes 2t, the fraction's a log. Okay, and that goes from 0 up to 1. So we sub it in. A lot of it vanishes, which is convenient, and we get this answer here. Okay, now this is, remember, a negative distance, which means now if you type this number 2 minus 4 log 2, if you type that into your calculator, you should see that it gives you a negative answer. Okay, so because it's a distance we're interested in, I might flip it and say, well, the distance traveled then is, it shouldn't be a negative, it should be a positive distance traveled. And so I'm going to flip it and say it's 4 log 2 minus 2. Okay, you check the calculator, that's going to be the positive number that we're looking for. Okay. Then we're going to go for the next length of the journey, the positive distance. Okay, and this time we're integrating the time from 1 to 7. Okay, and so that's the limits of our integral. Now, of course, the integration happens exactly the same way, just the limits are changed, and so we sub in some different numbers, and we simplify as best as we can. But this time the distance is exactly the answer of the integral, okay, because it's all positive distance already. Okay, and so now all that's left to do is to merge these two distances together, like so. The total distance traveled will be the sum of the two distances we just calculated. Okay, and so we just collect some like terms. Negative 2 plus 12 is 10, 4 log 2 plus 4 log 2 is 8 log 2. And you notice also I've changed the 8 into a 2 cubed. Okay, reason for that is because now we can use a little log rule to throw the 3 outside. 3 4s give me 12, and that lets me simplify one last time to 10 minus 4 log 2. Okay, and so that's the question there. Now you might want to look at that last part of this again if you need to, because it is a bit tricky with the particle changing direction and so on. But the takeaway is that in a question where we want to find the distance traveled, the total distance traveled, okay, we do need to split it into the negative and positive lengths of journey sometimes. Okay, so thanks for watching.